are back to the fat twin just as soon as I find my pen. And I found my pen. All right, so without replacement, what is the probability of drawing a red card and then a jack? So this is one of those where you have to think about situations. And that's kind of the issue with most people in probability. So it's a 52 card deck. The probability of being red is a half, okay? Now, first off, let me talk about order. You could get a red card and then a black jack, or a red card and then a red jack. That's a situation, because what if the red card you pulled out earlier was a red jack? So you could have a problem here. And you need to think about that, because it just says red card. It could have been a red jack and then another red jack. So things change up a little bit here. So the classical approach to this would be to say, okay, a red card, there's 26 and 52, and which means multiply, or just a jack in general. If you haven't pulled a card, if you haven't pulled a jack yet, there's still going to be 4 jacks in the deck, but it has reduced down to 51 cards. Now you have the word or, which means add, because these events are somewhat independent of each other, because this is the other scenario. Or you pull a red card, which is still 26 and 51, and that's the thing, it's red, it might be a jack, okay? You just don't know. And then a red jack. Now here's the deal, if you've already pulled the red jack, there's no longer 4 in the deck, there's 3. That should be a 2. So there's my scenario, okay? That's what I have to do. And it's more or less an endeavor in button pushing at this point in time, but you know, 26 over 52, that's a half. We have a half times 4 over 51. You do have to realize that the number of cards in the deck has decreased. This is 2 51sts, which do it by hand, you see a lot quicker. The other side here, we've got 26 over 52, which is a half. And we're going to multiply it by 3 over 51. That should be 3 over 102. One over 34. Yeah, that would reduce that. And then we add these two things together, and we see what we get. Some of you guys haven't quite figured out how to use your calculator yet, and you just sit there and waste all your life pushing buttons. 7 and 102. That's the odds of that happening. You could do this thing with permutations if you wanted. It is a permutation because there is some essence in order. It's got to be a red card and then a jack. So it has established order. If you want to do permutations, you still have to think about the 2 different scenarios. So I don't know that permutations buys you anything. But if you use permutations, it's going to be not a pretty setup here. I don't even like what I wrote. Yeah, I'm not going to write down what I wrote. I'm not a huge fan of using permutations for problems that you can reason another way. Billy is drawing 2 cards without replacement. What is the probability that he draws a queen and a jack if order does not matter? Okay, let me go back to that one. If you want to do permutations on this thing, it's kind of hideous, and permutations almost give me a headache. It would look like this: 52 pick 26 times 51 pick 4, because here's where we get 26 red cards out of 52. Here's 4 jacks out of 51. And the or situation, which is 52 pick 26, and then a jack. Well, maybe your jack was a red card, so now it has changed to 51 pick 3. And that would be divided by the total number of ways I can pick two cards, which is 52, pick two. And it's kind of a bear to punch that in a calculator, but it ends up being the same thing. It's 7 and 102. It ends up being the same thing. If you can think like that, more power to you. I'm not a huge fan of that. But that might just be experience. I wasn't taught permutations. All right, what do we got here? Billy is drawing two cards without replacement. What is the probability that he draws a queen and a jack if order does not matter? So this one could actually be done with combinations if you wanted to, and it wouldn't be too bad. But order doesn't matter. So here's your two situations. We have a queen followed by a jack, or we have a jack followed by a queen, because order doesn't matter. And that's a big thing. It says order doesn't matter. So the probability of drawing a queen is going to be 4 in 52. And if I pull the card, the probability of a jack is going to be 4 in 51. Okay? Notice that I've decreased the denominator because I pulled a card out. The word or means add. So now the probability of a jack is 4 in 52, but the queen is 4 in 51. And I can push some buttons on that one. Got 4 over 52 times 4 over 51. And some of you may not realize this, but both sides are the same thing, aren't they? Math, enter, enter. We get 4 in 663 on each side. And 4 plus 4 is 8, so it's 8 in 663. Now, this one's not too bad. It says order does not matter, so I can use a combination. And I still have to kind of do the combination the same way. And it's kind of funny how you set this one up. But there's 4 queens in a deck, so 4 choose 1. There's 4 jacks in a deck, 4 choose 1. That handles the first situation, or which is add, 4 jacks in a deck, choose 1, times 4 queens in a deck, choose 1. And I'm picking 2 cards, so the bottom would be 52, choose 2. So again, that's one way of doing it. I don't like that technique. But you do you. All right, here we have a table that we get to finish, and we love tables. So 29 minus 17 is 12, always has been. 70 minus 29, I feel like that's 41. Deep in my soul, I feel that's 41. 41 minus 23, I feel is 18. And I don't think these things are right. This looks like some made up stuff. And 70 minus 35 is 35. And I can check myself. 17 plus 18 is 35. 12 plus 23 is 35. 29. Okay, I'm good. All right, complete the table. If a kid is picked at random, find the probability that the kid is a left-handed boy. There's 17 left-handed boys out of 70. Some of y'all just throw the number you see and you don't even think about the divisor. Remember, probability is the number of desired outcomes over the total number of outcomes. I had 2 honors kids in first period just writing down the number, not even thinking about it being probability. They probably don't even know that probability is a number stuck between 0 and 1. It cannot exceed 1 and it cannot be less than 0. Don't be that kid. Like, I understand you're ready for school to be done, but it's too early to be mentally done. All right, find the probability of picking a girl given they are right-handed. All I care about here is the right-handed stuff. Oops, I should not have done that. I care about right-handedness. There are 41 people who are right-handed, and there are 23 girls. So 23 and 41. That does not reduce. Find the probability of picking a kid given they are a girl or left-handed. A girl or left-handed. Now I want you to note that there is overlap. there is such a thing as left-handed girls. You can be a girl and also left-handed, so you have overlap. So the probability of being a girl is 35 in 70. And then we have the word or, which means plus. Being left-handed is 29 in 70, but you have to take away the overlap. How many of these girls are also left-handed? There's 12 of them. You cannot count something twice. And anyways, we just do the math here. 29 minus 12 is 17. 17 plus 35 is what, 52? And we reduced fractions. I had a number of honors kids who were not reducing fractions. 26 over 35, assuming I did everything right. Now, the overlap is a lot easier to see in a Venn diagram. So given they are a girl or left-handed, we have girl, we have left-handed, and there are 12 girls who happen to be left-handed. So 29 minus 12 is 17, because there's supposed to be 29 people in that circle. And girls is going to be 35, but I've already counted for 12. 35 minus 12 is what, 23? Seems like I've done something wrong. Oh. I feel like I've done something wrong. Oh, no, I haven't. Just add the things up. 23 and 12 and 17 is what I got to add. So that's going to be 29 and 23, which is 52. Sorry, I'm tired. All right, consider the Venn